Okay, so we already know that if we know the slope m, the y-intercept b, then the line equation is y equal to mx plus b. Okay, so the line equation is determined by the slope m and the y-intercept. So in the seventh part, we are going to identify the slope and y-intercept of a line from its equation. Okay, so basically we will have an equation, and then we're going to say what is the slope, what is a y-intercept. This is the title of the seventh part. The theory behind the seventh part is this slope-intercept form. So for example, if we have y equal to negative 2x and plus 7, then we know that the slope is negative 2. Be careful here, you always include the sign if it has negative sign. The slope is negative 2, and the y-intercept is 7. Y-intercept is a number, it is equal to 7. Alright, so that's the idea of this the seventh section. Okay, for example, let's have some standard example. So find the slope m and the y-intercept b of the equation 2x plus 4y is equal to 8. Graph the equation. Okay, so we do have an equation, but the equation is not in such slope-intercept form. Slope-intercept form, just y is equal to certain mx plus b. This is a slope-intercept form. But now it's not in such form. So the step we're going to start is to transform this to the slope-intercept form. So we first copy this equation, and then we're going to move this 2x to the right side. It becomes negative 2x plus 8. And be careful, in the slope-intercept form, y has no coefficient, so we have to divide the whole equation by 4. We divide all the terms by 4. We get y equal to negative 1/2 times x and plus 2. Alright? From here we know the slope is negative 1/2. The y-intercept is 2. Slope y-intercept is 2. Alright? Okay, so that's answer for the first half, find the slope and the y-intercept. And second part, we need to graph the equation. The equation represents a line, so basically we're going to graph this line. 1 and 2, this is y part. 3, 4, 5. 1, 2, 3, 4, 5. -1, -2. 1, 2. -3 and 3 here. Okay, so y-intercept is 2, means this line will pass through the point 2 on the y-axis. And the slope is negative. Negative means you're going to move to the left. And remember, slope is equal to rise over run. Rise is about the y, run is about the left. We're going to move to the left. I'm sorry. Rise is about y, run is about x. And the negative coefficient means we're going to move to the left side. So rise over run is 1 over 2. So run is 2. So you start from here, you move to the left 2 units. 1 and 2. And the rise is 1, so you move up 1 unit. 1. And then you use a ruler. So this is going to be the line equation. Okay? Negative slope means you move to the left about the run. Rise is always up. Rise is always up. Alright, so this is a graph of the line equation. Let me see if we have another. Yeah, let's do another one. For example, let's just have on page 179, problem 90, we have 3x plus 2y is equal to 0. 3x plus 2y is equal to 0. We're looking for the same question. We're looking for the slope. We're looking for the y-intercept. So we do the same thing. We just leave y term in the left-hand side, all other terms in the right-hand side. So we move 3x to the right side, it's negative 3x. And then you divide the equation by 2, you get y is equal to negative 3 halves times x. No, plus 0 you don't copy. So you know that the slope is negative 3 halves. The y-intercept, you don't add anything, y-intercept is 0. Y-intercept is 0. If you try to sketch the graph, 1, 2, 3, 1, 2. So first it passes through the y-intercept 0. Y-intercept 0 is here. And it's negative slope, so you're going to move to the left side. Run is 2, so you move 1, 2. Rise is 3, 1, 2, 3. Okay, so this is the line. Run is the denominator. You see, run is the denominator. So you move to the left 2 unit and move up 3 unit. So rise over run. Okay, so all the problems on page 179 from 71 to 90 are about this type of computation. 71 to 90, all these problems are about the sketch of graph and to find the slope and the y-intercept. Okay, so let's see. So far what we have learned. We learned that if we have a vertical line, then it is x equal to a. if we have a horizontal line, it's y equal to b. Certain number, a and b represent whatever number. If we have other line with a slant slope, then we will have y equal to mx plus y-intercept b. So this covers all possible equations. And from here, you see this example, it's not in such form, but this equation still represents a line. And all these equations belong to a so-called the general form. So part 8, we're going to study the general form. Graph lines written in general form. Using intercepts. So first, what is a general form? Let's see the definition. The equation of a line is in general form when it is written as ax plus by is equal to c, where a, b, c are real numbers. And of course, if a, b are both 0, then c has to be 0. You get 0 over 0, it's nothing. So specifically, we require and a and b are not both 0. A and b are not both 0. You cannot get 0 together. Because in this case, if a and b are 0, so this is 0 plus 0 is equal to 0. C is also 0, right? Okay, so this is the definition. This is our definition. Now let's see why we say it's a general form. Because a general form will cover all possibilities. For example, if a is 1 and b is 0, a is 1, b is 0, b is 0, there's no y, so you will get x equal to c. This is a vertical line. Right? It's a vertical line. And second, if a is 0, b is 1, a is 0, no x, b is 1, so you get y equal to c. It's a horizontal line. In general, you see here, this one is 0, this one is 0. So you get, if both of them are not 0, we don't need both of them not 0. If b is not 0, let's check. I'm going to move a to the right side, so we'll get by is equal to negative ax and plus c. Because b is not 0, we divide the equation by b. We will get y is equal to negative a over b times x and plus c. This is, c over b, my bad. C over b. This is negative a over b times x plus c over b. Let me write this again. This is a slope-intercept form. Slope-intercept form. So that's why we call it the general form. It will cover all possibilities, horizontal, vertical, and other slope-intercept form. And by the way, the horizontal line is a special case of slope-intercept form. If a is equal to 0, b is equal to 1, you can still do that, just this part disappear. All right? So when we talk about slope-intercept form, we actually exclude vertical line because vertical line does not have slope. And when we but when we talk about the general form, we include all the slope-intercept form line and vertical lines. So it covers all possibilities. It's a great general case. All right. So now let's see the the computation related to this part. The general form has its advantage, and general form also has its we cannot say disadvantage, but indirect part. Because if we have the slope intercept form, we can directly say, okay, intercept is b, slope is m. But when we talk about general form, we couldn't directly, read the slope and the intercept. We have to do a little bit computation. Okay, so let's see, this is how we do the computation. Graph the equation. Graph the equation 2x plus 4y is equal to 8 by finding its intercept. Okay, so we're going to graph the equation by finding its intercept. What does it mean? It means, for example, this is not, assume the intercept, y-intercept here, x-intercept is here, then you just connect them. This will be the line. Or if you have y-intercept here, x-intercept here, then you connect them, you get a line. Or if you say you only have x-intercept, you have no y-intercept, what is it? Okay, if there is only x-intercept, the line is vertical. Okay, if there's just x-intercept, no y-intercept after you look for, then it is a vertical. If there is only y-intercept, just a y-intercept, the line is horizontal. Okay, if you only have one y-intercept, no x-intercept, then line is horizontal. So that's a two extreme case. And in general, if you have two intercepts, you just connect them. Either x and y-intercept, you will directly connect them. Okay, so let's talk about this problem. We have the equation general form 2x plus 4y is equal to 8. To find the x-intercept, y is 0. You let y be 0. Y is 0. You get 2x equal to 8, then x is equal to 4. So x-intercept is x equal to 4. To find the y-intercept, x is equal to 0. Y-intercept, x is equal to 0. X is equal to 0, this term is 0. So you get 4y is equal to 8, then y is equal to 2. Alright, so now let's try to sketch them. 1, 2, 3, 4. 1, 2. So x-intercept is a 4. This is a 4. Y-intercept is 2. This point is 2. We know that every 2 points uniquely determine a line. So that's it. That's what we call graph the equation by finding its intercept. Alright, you see, it's not that difficult. You just set one variable equal to 0 and look for the solution about the other variable. Okay? Good. And let me see. The problem from 91 on page 179, from 91 to find the equation of to 102. All these possibly 101, 102 are not this type, but like to 100. This is 10 problems. From 91 to 100, all 10 problems are about this type of stuff. You have the general form, you're looking for the x-y intercept, and then you graph the equation. Okay? So try to do the exercise. Try to do the exercise. Alright, so the part 9. Part 9, we're talking about an important geometric condition, parallel lines. Find equations of parallel lines. What is a parallel lines? Parallel lines just means two lines have the same direction. Oh well, let me really draw two parallel lines. This way, this way. Okay, yeah. Well, if my pencil is straight, then these two lines are parallel. Parallel line has exactly the same direction. Well, how do we describe the direction? We use slope to describe the direction. Right? We use slope to describe direction. So parallel line means slope are the same. If you have two lines, they share the same slope, then they will be parallel. Okay? And of course, whenever we talk about slope, we mean non-vertical line. And of course, and naturally, two vertical lines are parallel. Two vertical lines are parallel. If you already have one vertical line and have another vertical line, then definitely they are parallel. They share the same direction, just one direction, up and down direction, right? So what is a criteria for parallel lines? So the criterion for parallel lines. Two lines are parallel if they both have no slope. Both have no slope means they are both vertical. This is one case. Or they have the same slope. If they have the same slope like this, or they both have no slope like this. Okay, so this is a case, the criterion, like the rule to determine two lines are parallel or not. Okay, so for example, if we have y equal to x plus 1 and y equal to x plus 2, these two lines are parallel because they share the same slope 1. Both have the same slope 1. All right, so it's very easy to determine if they are parallel or not. So from here you can see that to determine the parallel condition, we just check the slopes. Now let's see. Show, you see here we are going to do some proof. Show that the lines given by the following equations are parallel. L1, line 1, it is given by 2x plus 3y equal to 6. Line 2, it is 4x plus 6y equal to 0. Right? Solution. How do we know? How do we show they are parallel? We just try to check the slope of the first line and the slope for the second line. Okay, so let's check. For the L1, 2x plus 3y is equal to 6. We're going to write this in the slope-intercept form, because in the slope-intercept form, we can directly mention what is the slope. We'll move 2x to the right side, negative 2x plus 6, and divide the equation by 3, we get y is equal to negative 2/3 x plus 2. So the slope is negative 2/3. Y-intercept is 2, right? Slope, y-intercept. This is L1. We find the basic information. For L2, 4x plus 6y is equal to 0. We move 4x to the right side, negative 4x, and divide by 6, y is equal to negative 4 over 6x. Negative 4 over 6, you cancel 2, you get the negative 2/3 of x. So the slope is negative 2/3. Y-intercept is 0. Okay, they share the same slope, they have different y-intercept. Different y-intercept means you really have two different lines. The same line will have the same y-intercept. Okay, so because two lines have the same slope, negative 2/3, different y-intercept, they are parallel. They are parallel. Okay, so this is a criterion. Two lines, they share the same slope, they share parallel. Why do we mention they have different y-intercept? The thing is the following. When we have this so-called the general form, we really don't know if two equations will give us the same line or not. For example, 2x plus 4y is equal to 0, and 3x plus 6y is equal to 0. These two equations are different, right? Yeah, we do have two different equations. But if we divide this equation by 2, we will get x plus 2y equal to 0. We divide this equation by 3, we still have x plus 2y equal to 0. Actually, you can see that this L1, line 1, is exactly line 2. If you have just one line, you couldn't say they are parallel. One line, it is not parallel to itself. Okay? So this different y-intercept just guarantee in our discussion, we do have two lines. Okay? Two lines with the same slope are parallel. Okay, that's the translation. Two lines with the same slope are parallel. Okay, so that's a slope criterion for the parallel lines. When you have two lines, you can determine they are parallel or not. Another geometric question is that I already have a line. I have a point outside the line. I want to determine the equation of the line through the given point, exterior point, outside point, parallel to the given line. Okay, I give you a line, I give you a point, I'm looking for the line through the point, parallel to the given line. Find the line through the given point parallel to the given line. Okay, this is a natural geometric question. All right, let's see how do we do it. Let's do one example. So example, find an equation for the line that contains a point, pass through the point, the same meaning. Contains a point 2, -1, and is parallel to the line two x plus y is equal to 6. Okay, so we're looking for the equation of a line with this point parallel to the given line. We already have a point on the line. If we know the slope, we have point slope form. So assume the required line has a slope m. Assume the required line has a slope m. Because the required line is parallel to the given line, this m is also the slope of the line 2x plus y equal to 6. They should have the same slope, right? This m is also the slope of the given line because they are parallel. Because these two lines are parallel. Right? Two lines are parallel, then they have the same slope. I repeat this. Okay, so what is the slope of 2x plus y equal to 6? 2x plus y equal to 6. We move 2x to the right side. Negative 2x plus y is a 6. Y is equal to negative 2x plus 6. So the slope is what? Is negative 2. Because this is a slope-intercept form. Slope is negative 2. It is equal to m. M is a slope. Slope is negative 2. So m is negative 2. M is negative 2. You have a point. The point slope form is y minus y coordinate is equal to slope times x minus x coordinate. It's a required equation. Find an equation. This is a required equation. Okay? Don't ever simplify it. Don't ever simplify it. Alright, so that's the equation. Well, let's see if we have a second method. This one we use the slope point or point slope forms. But the original equation is in the general form. How do we know two lines have a slope if we directly have general forms? A1x, B1y, C1. If two lines A1x, B1y, C1, A2x plus B2y equal to C2 are parallel, then A1 versus A2, B1 versus B2 are proportional. What I mean is the following. I'm not so sure if I'm writing this sentence in the right way, but this ratio are equal. So basically, I'm trying to say this ratio is equal. But if I write a ratio, I also have problem. I have to guarantee both of them are not 0. But anyway, let me show you. So if I have 2x plus y is equal to 1 and 3x plus 2, not 3x, 4x plus 2y is equal to 10, then I can claim those two lines are proportional. Those two lines are parallel. The reason is that you see here, you just multiply the first line by 2, you multiply the first line by 2, you will get 4x plus 2y is equal to 2. Here you see that 4x plus 2y, 4x plus 2y. They share the same xy with a coefficient, but different c. They share the same xy with a coefficient, but different c. Then these two lines are proportional. Two general forms are proportional if you can multiply one equation by a proper number and change the xy part identical to the other one, then they are proportional. They are parallel, my bad. They are parallel. Okay, so back to this problem. If we know, if we're looking for the line equation parallel to the given line, we're doing the following thing. Let the equation be 2x plus y equal to c. Okay, why we set up the equation like this? Because with this equation, we do have 2x plus y. Here is 2x plus y. They share the same form. Then automatically they are parallel. So we use this condition to have such setting. The only unknown letter is c. How do we determine c? This line contains the point 2, 1. So x equal to 2, y is equal to -1. You plug in, x is 2, you get 2 times 2 is 4, y is equal to -1 plus -1 is equal to c. So this implies c is equal to 3. C is equal to 3. Well, let's try. So the equation is 2x plus y is equal to 3. That's it. That's it. We can show they are the same thing. So from here, y minus -1 is y plus 1. -2 times x, -2x. -2 times -2 is plus 4. So you move 2x to the left side, 1 to the right side is 2x plus y is equal to 3. See, they are exactly the same thing. I have method 1 and method 2. It's up to you to use in the exam. For the method 2, we have the parallel condition, then we set the equation to be 2x plus y equal to a unknown c. This c will control the y-intercept, but we don't care. The geometric meaning, we just know we don't know what this is. You see here, this is 2, this is 10. They're different, but what the value they should be, it depends on the point. First, you set up 2x plus y equal to c, and second, you plug in the point coordinates. X equal to 2, the 2 times 2. Y is -4, and this should also be summed together, should also be c. So c is equal to 3. Alright, so try to do the corresponding exercise. Let me see. The 59 to 64. 59 to 64 on page 179 about the parallel problems. So you should be able to do them. Okay, I finished this video at this moment, and we will continue the discussion in the next video. Thank you. Let me show you the pages I have discussed. So we start from this page. Second page. Third page. Fourth page. And the fifth page. Okay, thank you.